All right, hello Pre-Algebra. We are going to be looking at a brand new topic, and I think this is going to be kind of fun. Change of pace. It will be probably brand new stuff for you, which I think is fun. So, quick disclaimer, any loud cheering you hear going on, it is the Chiefs game right now, so Mr. Mo may be heard in the background. I'm just warning you. So, we touched on this warm-up question a little bit in class on Friday. The argument whether x squared is the same as 2x. So that is just kind of to introduce our topic for today. So we'll talk about this more in class, but you'll have a lot more ideas after today's lesson. So today's learning goal is to evaluate square roots and cube roots and use square roots and cube roots symbols to represent equations. So we're going to write these equations in the form of x squared equals p and x cubed equals p. So I know you're already wondering what in the world cubed means and what cubed roots are, so let's check it out. Okay, so our key concept, we're going to start first in this lesson by talking about squares and square roots. So perfect squares. A number that is the square of an integer is a perfect square. For example, 2 squared, I would write that in numerals like this, a base of 2 with a superscript of 2, 2 squared, and that literally means 2 times 2. So remember, your exponent is telling you how many times your base is a factor. So 2 is going to be a factor twice. So 2 times 2, which is 4. So when we say 3 squared, we write that mathematically as 3 to the second power, which means 3 is a factor twice. 3 times 3, which is 9. 4 squared means 4 is our base, 2 is our exponent. This literally means that 4 is a factor twice. So kind of a shortcut for writing multiplication. Now we can also square negative numbers, so we have to keep those integer rules in mind. So negative 2 squared means that negative 2 is a factor twice. So negative times a negative always makes a positive, so negative 2 squared is also 4. In the same way, negative 3 squared, negative times a negative makes a positive. So 3 squared is 9, and negative 3 squared is 9. And finally, negative 4 squared means that negative 4 is a factor twice, which gives us positive 16. Now notice we have put our base, when it's negative, inside parentheses. This is very important. This is not the same thing as this. So my exponent only affects what it is directly touching. So in this first example, my 2 is only touching this 2. So I am saying that I'm taking negative, or the opposite of, 2 times 2. However, on the other side of my equation, my exponent is touching the parentheses. So I have to square everything inside the parentheses. So over here, I'm saying negative 2 times negative 2. So we get different answers. So make sure that you keep that in mind, that the way you write it or notate it is important. Okay, in the reverse, if we're thinking of a square root, the square root of a number is another number that when multiplied by itself is equal to the original number. To me, square root is more difficult to define than to actually understand. So this is our square root symbol, the square root bar. So whenever you see this over a number, know that we are looking for the number that when multiplied by itself equals this. So when I see the square root of 4, I'm saying what number times itself equals 4, which of course we know to be 2. Now you'll notice here that we have a little side note that in this program, meaning digits, that this square root bar means the positive square root of a number unless stated otherwise. And that's because truly the square root of 4 could be positive 2, or it could also be negative 2. So often you will see this written like this with a plus sign right above a minus sign, and this is read plus or minus 2, meaning positive 2 and negative 2 are both part of the solution here. So the same when we take the square root of 9, we know that the one number I can multiply by itself to get 9 is 3, but truly it could be the positive version of 3 or the negative version of 3. But let's take a look at what this looks like in just a moment. So just so we understand the relationship between squares and square roots, squaring a number and taking the square root are inverse operations. And this is a little tidbit that you will want to file away and keep in mind for down the road, and certainly in algebra next year, that just in the same way as addition and subtraction are inverse and they undo each other, and the same way that multiplication and division are inverse operations and they will undo each other, so will squaring a number and taking the square root. So when we say 3 squared is 9, that's squaring the number. And when we say the square root of 9 is 3, that's taking us back around full circle. So let's look at how we're actually going to use this mathematically. And we'll kind of talk about the equation x squared equals p. And basically, p is just going to stand for the square root of x. So when we say, what does x squared equal 4 mean? What we're saying is that 2 squared, which would be 2 times 2, equals 4. And negative 2 squared equals negative 2 times negative 2, which is also 4. So x equals 2 and x equals negative 2 would both be solutions. Or, like we talked about on the previous screen, the simple way to write that is x equals plus or minus 2. So that's kind of a key concept for you to pull away, but I want to show you how we'll actually use this in an equation. So if we have to solve an equation like this, then we are going to take the square root of each side of the equation, because remember, squaring and taking the square root are inverse operations. So whenever I'm solving equations, I want to get the variable all by itself in its most simplified form. So to do that, I need to undo my exponent here. So the opposite of squaring x would be to take the square root. So here we have an explanation of the steps and then mathematically what it looks like. So we start with our given equation, x squared equals 100. We want to solve it. In other words, we want to know what x equals. My next step is to take the square root of each side, which I can show by simply putting the square root bar over each side. Notice over here that we have indicated that the solution could be positive or it could be negative. And now for my next step, I'm going to simplify the square roots. Remember, taking the square root of a number that I'm squaring, those cancel each other. So the square root of x squared equals x, and the square root of 100 equals 10. So the solutions would be positive 10 and negative 10. And if I want to check my work down here, which I always do, then I can substitute each of these solutions back into my original equation. So if I substitute 10 in for x, 10 squared equals 10 times 10, which is 100. That checks out. Or if I substitute negative 10 in here, negative 10 squared means negative 10 times negative 10, which also equals 100. Okay, so let's try out a couple here. Let's do A and B together, and then you can pause the video and do C and D on your own. I need to solve each equation, which means I find the value of the variable. So I want to undo this exponent. So the opposite of squaring a number is to take the square root. Whatever I do to one side, I have to also do to the other. But I'm going to take it back a step here, and I'm going to rewrite this so I have a little more room, because when I take the square root of 4, I want to remember to include the positive and the negative version. So now I'm going to simplify. The square root of x squared is x, and the square root of 4 is plus or minus 2. So my solutions are 2 or negative 2. So on part B, I'm going to do the same thing. To solve, I need to get x simplified and by itself. So I'm going to rewrite the equation, giving myself a little more room here. So I'm going to take the square root of both sides and now simplify. The square root of x squared is x. The square root of 81 is positive minus 9. So my solutions are 9 and negative 9. Go ahead and pause the video and give yourself a chance to solve letters C and D, although I bet you can do it in your head. As I take the square root of both sides, I'm remembering that I need to consider positive and negative 7. And on letter D, same thing. And hopefully you came up with solutions of 4 and negative 4. All right, let's try one more here that requires a little more work. So I'm going to solve y squared equals 625. So I'm going to rewrite my equation so that I have a little more room to work here, because I know if I want to solve, I need to find the value of the variable, which means I need to get rid of this exponent. And the opposite of squaring a number is to take the square root, so I'm going to do that to both sides. However, my solution, I need to consider the positive and the negative version. But we might be stuck here on how to do this. Many of us will not know in our head the square root of 625. You can easily do this on your calculator. On your scientific calculator, you will have to use the second function button, and I can help you in class with that if you're stuck. And then you will have to find the key that has the square root bar on it. Or I'm sorry, you're going to look for the button actually that says x squared. And if you press second first, the second function of this key is to take the square root. So you can do second function, this button, and then type in the number that you need the square root of. However, if we don't have a calculator handy, you can make your list of perfect squares and use that as well. So one thing that I did was just quickly think in my head about some common squares. So I know that if I square 20, 20 times 20 is 400, or if I square 30, that 30 times 30 is 900, but I'm looking for 625, which is going to be somewhere in the middle here. So then I just checked 225 and I squared, or I'm sorry, 25, and I squared 25 quickly and found that that is indeed the square root of 625. But if you have trouble figuring out how to use this button on your calculator, I can help you as well. Okay, so let's take a look at another problem here. If we are solving a squared equals 64 over 81, don't let the fraction intimidate you. Just think about the steps that we've been using. So let's start by writing the equation. That way we have a clean copy and we have plenty of room to do the work that we need to do. My next step is to take the square root of each side. Remembering that in an equation, whatever I do to one side, I always have to do to the other to keep it balanced, just like a fraction. And now I'm going to simplify my square roots. So the square root of a squared is a. The square root of 64 over 81 is going to be positive and negative. I'll consider both. And now I'm simply going to take the square root of the numerator. So the square root of 64